Welcome back to How'd You Get That? Last time we talked about what physics actually is, and that at its core, it is describing how energy evolves in a system. So today's question is this. Take these three physical systems, a swinging pendulum, the Earth orbiting around the sun, and an electrical circuit with a light bulb and a battery. How are these three physical systems similar in terms of their energy considerations? Though these three systems might look very different to us, the swinging pendulum seems to not have anything to do with the elliptical orbit of the Earth, which seems to have nothing to do with an electrical circuit that passes electrons through a light bulb and back to a battery and so on. But it turns out that these three physical systems are quite similar in a lot of ways. Let's take a look at how they relate to each other in terms of energy. We already talked about the pendulum last time, but let's go over it again. As I swing the pendulum through its motion, it gains potential energy as it rises in height and loses kinetic energy. As it falls back down, it loses potential energy and gains kinetic energy. At the height of its motion, it has zero kinetic energy because it's stopped, and it has maximum potential energy. At the bottom of its motion, it has zero potential energy because I'm going to define zero potential energy to be at that point, at the bottom of its motion, and it has maximum kinetic energy. If we look at the total energy of this system, we see that it is constant. Assuming there's no friction involved with this pendulum, the total energy is constant. That means that the maximum potential energy at the height of its motion is equal to the maximum kinetic energy at the bottom of its motion. If we look at any 2 points in this pendulum's motion, if we add up the potential energy at that point and the kinetic energy at those points, then we see that the total energy remains conserved. It remains constant. This is known as the conservation of energy. But what about Earth's orbit? Well, the Earth orbits around the sun in an ellipse. It looks mostly circular, but it turns out that it is actually elongated into an ellipse, which means that the Earth has a point of closest approach, the perihelion, and a point of furthest approach, the aphelion. At these 2 points, we can compare the kinetic energy and the potential energy of the Earth. As the Earth gets closer and closer to the sun, we can see that its kinetic energy increases because its potential energy decreases. And as the potential energy increases as the Earth gets further and further away from the sun, the kinetic energy decreases. So again, we have this push and pull between kinetic energy and potential energy that describes the nature of this system. Okay, let's move on to the electrical circuit. How is this related to those other two situations? Well, we can see here that both the battery and the light bulb have something called a potential or a potential difference. As electrons pass through the battery, they are ratcheted up in their energy, in their electrical potential energy, to get to a point where they can travel now through the wire and to the light bulb. Because of this potential gradient, as it's sometimes called, which is analogous to a hill that a ball can roll down, the electrons can travel through the wire. And they also then pass through the light bulb. At this point, they pass through the light bulb heats up due to the energy in the electrons, and it radiates that energy away in terms of light. And as we then get back to the battery, the whole process starts over again. The energy of the electrons is increased as they pass through the battery, and then they're decreased as they pass through the light bulb. Instead of having kinetic and potential energy in this situation, we have potential energy, electrical potential energy in this case, and we have heat and radiant energy as it passes through the light bulb. We also have chemical energy that imbues the electrons with energy as they pass through the battery. But again, we are going through the process of gaining potential energy, losing potential energy, and we have this cyclical motion in the circuit, just as we do in these other situations. And though energy in this situation is not conserved, it's radiated away from the light bulb, energy is transformed between potential and other forms of energy. So that's how these three very different situations all link together in terms of their energy considerations. If you have any questions, leave them in the comments below, along with what you'd like to see in future episodes of How'd You Get That? Hit that like button, subscribe, and hit that notification bell so you never miss another math, physics, or problem-solving tutorial. Thanks so much for watching, and I'll see ya in the next problem.